Out in the far reaches of our solar system, in the shadow of the magnificent Saturn, lies a world so strange that it has captivated the minds of scientists and explorers for centuries. This world is Titan, Saturn's largest moon, a place where the familiar laws of nature take on an entirely new form. Titan is not just a barren rock or a frozen wasteland. It's a moon with a rich, dynamic environment, teeming with mysteries that we are only just beginning to understand. One of the most perplexing and awe-inspiring features of Titan is its methane lakes, vast, dark bodies of liquid methane and ethane that ripple and reflect in the cold light of its distant sun. These lakes hold clues to some of the most fundamental questions about chemistry, life, and the universe itself. Unlike Earth's oceans, which teem with water and life, Titan's lakes are filled with liquid methane and ethane, hydrocarbons that remain liquid only because of the moon's frigid temperatures. The surface temperature on Titan hovers around a bone-chilling -290 degrees Fahrenheit, -179 degrees Celsius, far colder than any place on Earth. Yet, despite these extreme conditions, Titan's lakes are part of a complex, active system that mirrors Earth's own water cycle. It's a strange, alien cycle, one that exists in the depths of coldness and darkness. But within these strange cycles may lie some of the most profound answers to questions about life itself. The lakes on Titan are vast, stretching for miles, some the size of Earth's Great Lakes, others even larger. These bodies of liquid methane and ethane form part of a complex hydrological system, one driven not by sunlight, but by Titan's unique atmosphere, its seasons, and the interplay between methane, nitrogen, and organic molecules. These lakes are more than just a curiosity. They are the beating heart of Titan's dynamic surface. The methane on Titan behaves in a way that we would expect water to on Earth. Like water on Earth, methane evaporates from the lakes and rivers, forms clouds in the atmosphere, and falls back to the surface as rain. This is Titan's version of the water cycle, where liquid methane acts as the solvent and the medium through which the moon's climate and weather patterns are shaped. However, the cycle on Titan is far colder, far more extreme. And that's what makes it so fascinating. Titan's atmosphere is thick and dense, composed primarily of nitrogen and methane. The air pressure on Titan's surface is 1.5 times that of Earth's, and the weather is driven by processes very different from our own. Titan's low temperatures and thick, hazy skies make it difficult to see clearly, but beneath that haze lies an environment that is constantly changing. The wind blows across the methane lakes, creating small waves, shifting the landscape in a subtle, ever-evolving dance. In some places, the lakes are still and serene, while in others, wind and seasonal changes cause ripples and movement, reshaping the land and water. Titan's methane cycle is not just a curiosity. It is a mechanism that shapes the very landscape of the moon. Liquid methane falls from the clouds, replenishing the lakes, rivers, and seas. The rainstorms can be intense, shaping Titan's surface much like Earth's storms carve out valleys and riverbeds. The methane rivers carve intricate channels across the icy crust, creating a shifting, dynamic landscape that is constantly changing over time. Even though Titan is a frozen world, its surface is anything but static. Titan's lakes and rivers are part of a living, breathing system. What makes Titan even more fascinating is not just the cycle of methane, but the rich chemistry that takes place in its atmosphere. Titan's thick atmosphere, bathed in sunlight that is only 1/7 as bright as Earth's, is a laboratory for the creation of complex organic molecules. These molecules, organic compounds, are the building blocks of life as we understand it. As sunlight interacts with the methane in Titan's atmosphere, it breaks apart, creating a whole array of complex organic molecules, some of which are similar to those that form the basis for life here on Earth. The organic molecules forming in Titan's atmosphere are key to understanding not only the chemistry of this world, but also its potential for life. While we have yet to find direct evidence of life on Titan, these molecules are a vital clue. They suggest that Titan may be a kind of chemical incubator where the ingredients for life, at least life as we know it, are being assembled in the cold and distant reaches of the solar system. Could life arise in such a cold, dark place? Could the molecules found in Titan's clouds somehow coalesce into life forms, adapted to the moon's extreme conditions? On Earth, life is based on liquid water. Water is the solvent in which all life processes take place. But what if life could exist in a completely different solvent? Titan's methane lakes may provide just such a medium. In these lakes, methane acts as a solvent, similar to how water acts as the solvent for life here on Earth. Could life, in some radically different form, arise in Titan's icy, methane-filled environment? We don't know for sure, but the possibility challenges everything we thought we knew about biology and the conditions required for life. Titan's surface is as strange as it is beautiful. Icebergs float serenely on the surface of the methane lakes, slowly drifting with the currents, while frozen mountains loom in the distance. The landscape is a surreal vision, both alien and familiar. The surface of Titan is composed mostly of ice, water ice, in fact, compacting and stretching over vast plains. Beneath this icy crust lies the real mystery of Titan, a hidden ocean of liquid water. Could this hidden ocean, shielded beneath miles of ice, harbor the necessary conditions for life? Could it offer a sanctuary for life that exists beneath the moon's cold, desolate surface? Scientists believe that beneath Titan's thick ice shell, there may be a subsurface ocean, one of liquid water kept warm by the heat generated by the moon's internal processes. This ocean, if it exists, could be one of the most intriguing places to search for signs of life. Water, after all, is a universal solvent that supports life in every known environment on Earth. Could it be that Titan, with its lakes of methane, its icy crust, and its potential subsurface ocean, could be home to life that is radically different from our own? In just a few years, humanity will begin the most detailed exploration of Titan ever attempted. NASA's Dragonfly mission will send a rotorcraft to Titan's surface, where it will fly across the moon's surface, sampling the methane lakes, analyzing the organic compounds, and studying the complex chemistry that is taking place. Unlike traditional landers, Dragonfly will be able to travel from one location to another, gathering data on Titan's diverse surface features, including its methane lakes, rivers, and seas. The mission will study the dynamics of Titan's weather, its atmosphere, and its lakes, providing unprecedented insights into one of the most fascinating worlds in our solar system. Dragonfly is designed to take samples from Titan's surface, from its methane lakes and rivers to its frozen landscape. It will seek out the chemical signatures of organic compounds that might hint at life, or at least the building blocks of life. As it explores, Dragonfly will search for clues to Titan's geological history, studying the composition of the lakes and the formation of its surface features. The data collected by Dragonfly will help scientists understand not only Titan's environment, but also the potential for life on this distant world. As we continue to explore Titan, we are confronted by one of the most profound questions in science. Could life exist beyond Earth? And if so, could it exist in a form we never even imagined? Life not based on water, but on methane? Titan's methane lakes, its complex chemistry, and the potential for a hidden ocean make it one of the most compelling places to search for life beyond our planet. Titan challenges everything we thought we knew about what makes a world habitable, and it may hold the keys to understanding the fundamental nature of life itself.